Okay, so welcome back to the thermodynamics class. So today we'll be solving our first problem. So I try to select interesting problems, not just problems from the textbook, but try to make real life problems. So for the first case, I actually went and tried to pick one from the 17th century. So basically this is the problem where you have a cylinder or two hemispheres, and this is, believe it or not, this is a pump. So basically what happened here is that when we close this, the engineer is going to create a vacuum between both of them, and it is said that for this experiment about 30 horses were needed in order to separate the two hemispheres. Okay, so this is the Magdeburg experiment, or Magdeburg experiment performed by Guernicke. All right, so let's go. So that's the Magdeburg. So Magdeburg is a city in Germany where the experiment was performed in 1654. Okay, and this experiment was actually performed in front of the emperor of Europe at that time, and basically was an important experiment because up to then the belief was that in order to have a force you need to have some type of medium, and this was the proof that in order to have a force you don't really need a medium, because here what we are doing actually is to test the strength of the vacuum. Okay, so let's try to do a little summary of the experiment. So there is two hemispheres this way, so you only can put a hook over here, and there's a sealer over here, or seal. The seal was just made of animal grease, and the diameter of the two hemispheres is about 50 centimeters, which is about 20 inches. Okay, so we put them together. All right, over here, and basically what we're trying to find is what should be the force that we need to do in order to separate them. So obviously outside we'll have the atmospheric pressure, and inside, obviously, if we have a perfect vacuum, the pressure will be 0. So over here this will be 1 atmosphere, which is about 29.92 inches of mercury. Okay, or this in metric units, this should be, I think it's 1,125 or 35, 113.25 kilopascals. Okay, so let us solve the problem. What we need to solve is what is F. Okay, so we'll go in detail later on, but I want you to show basically here the steps, the general steps in order to solve a problem. First thing you always need to do is some type of figure diagram to understand really what you need to solve for. Once you have the figure done, then you can write down an equation. So in this case, this will be like a static equation. You will say summation of forces on that system needs to be equal to 0. Okay, so what do you have over here? You will have the two forces over here needs to equal the force inside created by the atmosphere, which will be P atmosphere minus P inside. And as you know, pressure is force times area, so we need to multiply this by the area of the hemispheres. Okay, so basically we just say that if we have the perfect vacuum, this should be equal to 0. So we're going to have over here that 2F will be equal to the P atmosphere times A, which will give you that the force is to be equal to the P atmosphere times A divided by 2. Okay, so now we just need to do the numerical application. So the area of the hemispheres is given by what? Is pi r squared, or in function diameter will be pi d squared over 4. So let's do the calculations. So what we're going to have? We're going to have F equal to 13.25 times 100 Pascal, which is Newton meter square, times pi divided by 4 times the diameter will be times 0.5 square, and all this should be divided by 2. So if you do this calculation, I did the calculation earlier, so we don't have to waste the time. You get that the force, the value of the force is 9,947.5 newtons, which is approximately 2,236.3 pound force. Okay, so remember the problem. We have the two hemispheres, and basically they wanted to know what was the value of the force. So in those times, in order to apply the force, so the whole experiment was that you had here the two hemispheres, and this was connected to, so this will be the force, and this was connected to horses. Okay, so let's find out what was the definition of the horsepower. So by definition, one HP, which is 1 horsepower, is defined as the required power to raise 75 kilograms, which is approximately 165 pounds, 1 meter, which is about 3 feet, in 1 second. Okay, so let's see what is the definition. So the power, generally we use the letter W, is by definition is equal to the force times the distance. Okay, so it will be 1 horsepower will be equal to what? Should be equal to the force created by the 75 kilograms, or the 165 pounds will be mg, times the distance is our 1 meter. So let's see what would be the force created really by 1 horsepower. So 1 horsepower basically will be equal to what? To our 75 kilograms times the gravitational acceleration, which is 9.81, and this is going to give us that 1 horsepower is approximately, so I did a calculation as well, about 735.75 newtons. Okay, so if you remember from the previous page, the total force required to separate the two hemispheres, so just on one side, so recalling from previous page that F was equal to 9,947.5. So that would mean that how many horsepowers do we need? Of HP will be equal to 9,947.5 divided by 735.75, which is approximately 13.52. So basically, that means that in order to separate the two hemispheres, because we cannot cut a horse in 52, basically we need 14 horses on each side of the hemisphere to be able to separate them. And this is just by looking at a 20-inch diameter. Okay, so you can see that the vacuum force is actually pretty strong. And that will be it for this first problem. Thank you for your attention.